So hello everyone, we are back again with part 9 of the video from the chapter Light, Reflection and Refraction. And in this video, we'll be talking about the most important thing which is required when we solve numericals. And the topic is sign conventions for reflection by spherical mirrors. So what we see here is representing basically the graph. And when we talk about graph, we have something in the graph which is like this. We have x-axis, we have y-axis, and if you have understood the graph, then I guess the concept of sign convention for spherical mirrors becomes easy. So when we talk about a graph, we have this point, basically as we discussed, that we have x-axis and we have y-axis, and we have this origin here. And we know there are 4 quadrants, 1, 2, 3, 4, and we have certain understanding of this quadrant that all the values on the x-axis in this quadrant are going to be positive. All the values on the y-axis in this quadrant are going to be positive. All the values in this quadrant of y-axis are going to be negative, and all the values of x-axis are going to be negative here. Now, if I'll consider this for my mirror situation, so let's say if I'll talk about mirror, so I'll create a setup. So this became my concave mirror. So if I'll just quote this side, so in case of concave mirror, the origin of the graph which we were considering becomes the pole. So as we were discussing that all the measurements are going to be taken from this point, which is going to be 0, which is basically origin for graph. And for the mirrors, whether it's a concave mirror or a convex mirror, we consider this as origin, or we call it as basically pole for the mirror. And all the measurements will be taken from this point. So whether you're going towards your right, you are going towards your left, the measurements are going to be from the center, which is called as basically pole. So how it goes that if you are keeping the mirror like this, obviously you're going to keep the object here, but there's no restriction. You can keep the mirror other way around also, and in that case the object will be here. But if you're keeping it like this, based on sign convention, first rule is like this, that all the measurements will be taken from here. If mirror is kept here, the object will always be kept on the left side. As per sign convention, we'll be keeping always the object on the left side. So now if I am keeping the object, obviously the light will come from the left side. So this is direction of light. So the sign convention goes like this, that all the measurements will be taken from the pole. Object will always be kept on the left side, as we have seen just now. The measurements, all the measurements in the direction of light ray. So we can see this red line indicate direction of light. So all the measurement in the direction of light ray will be taken as positive. So these are all the measurements which are in the direction of light ray, starting from origin or pole for the mirror, are taken as positive. All the measurements in the opposite direction will be taken as negative. Similarly, whenever we are keeping the object, we will always keep the object above the principal axis. So this is principal axis. All the measurements in the upward direction will be taken as positive, which is basically the height. And all the measurements taken in the downward direction will be negative. So these are basic sign convention. We will also try and understand how the statement goes ahead. Now, this was in terms of a graph we have understood. Let's also see basically in terms of mirror. So sign convention for reflection by spherical mirror. Now, again, it's written spherical mirror. It means these rules are valid whether you have a convex mirror or a concave mirror. So you can see here we have a mirror, concave mirror here. This is a pole. This is principal axis, and this is AB, which is our object. So as we discussed, and this you can see direction of incident light ray. So if object is kept here, light will come from this side. And if you invert it and if you keep the mirror on the other side, then object will be kept here. But as per sign convention, we keep the object on the left side. So all the measurements towards right, ideally we should not remember it as distance towards the right as positive, but we should say that measurements taken in the direction of light ray are taken as positive. So all the measurement in the direction of light ray are positive. All the measurements in the direction opposite to that of light ray are taken as negative. All the upward heights or above the principal axis measurements are positive, and below the principal axis measurements are negative. So based on this, we will also understand now. Right now we can see it's an inverted image, which means it's a real image. So if it is a real image, we will get certain situations of height. For virtual image, we'll get certain situations for height of object. So we can understand based on sign convention. Let's see what are the sign conventions. So as we are seeing it here, the first one, the object is always placed on the left of the mirror and the light from the object falls from the left to the right. So you can see object is kept on the left and light is falling from left to right. Going ahead, second rule goes like this, that all the distances parallel to the principal axis are measured from the pole. As I've discussed, that all the measurements will be taken from the pole. All the distances measured to the right of pole are taken as positive, which are these one you can see, which means if the measurements are going on this side, it means we are going to get the virtual image. All the measurements towards the left are taken as negative. Similarly, when we go ahead with the height of object, height measured upward perpendicular to the principal axis is taken as positive, and that below the principal axis will be taken as negative. So based on these, we will come up to certain conclusions. Let's have a look at those conclusions. What are the conclusions? Now, these conclusions are very important. You can note it down if you want to solve the numerical, because these conclusion forms the crux of all the numericals related to spherical mirror. So you, as we discussed, that we are going to keep object always on the left side, which means we are going to take measurements from pole and we are going to go towards left. That's why u is always going to be negative. So please keep that in mind, that u is, whether it's object is always going to be on the left side, so u is always going to be negative. When we are talking about the second case, which is v, now v varies. V would be positive for virtual images. As we have discussed, if it is a virtual image, we will get somewhere here, and we have seen how virtual images will be formed with the dotted setup. So basically virtual images are formed on the right side. So if the image formed is virtual, we will have uh, measurements. V is basically image distance, which is going to be virtual, and V is going to be negative for real images, which means measurement will be on the left side. It means it's a real image which is being obtained. Now, usually we have a confusion between what is U, what is V, and which is for object and which is for image. So we should remember that in English alphabet, U comes first and V comes later, and out of object and image, we will always be keeping the object first, and based on that only we will obtain the image. So U is for object, V is for image. Similarly, when we talk about H1 and H2, H1 is basically height of object. So one comes before two, so object comes before image. So height of object is H1. Object we will always be keeping above the principal axis. So H1 is always going to be positive. And based on whether it's a real image or virtual image, if it is a real image, we will get H2 as negative. But if it is a virtual image, if it is forming on the right side vertical, then it is going to be a positive image, which is going to be virtual. Some more conclusion. When we talk about focus of a convex mirror, so we know convex mirror forms virtual image, virtual focus, and virtual focus is going to be on the other side of the mirror, and that's why it is always positive. For convex mirror, focal length is positive, whereas that for concave mirror, as it is a converging mirror, on the left side it is formed, so it's negative. When we talk about magnification, magnification is negative for real images. We will also understand why. Right now, you can just keep this in mind. We will talk about what is the magnification formula, and from there we'll understand. Magnification is positive for virtual images. You can make a note of it. Magnification is positive for virtual image and negative for real images. Now, when we talk about magnification, there are few things we need to keep it in mind, that if magnification is greater than 1, then object size is less than that of image, which means image is magnified. If magnification is less than 1, image is diminished, image size is smaller than that of object. And if magnification is 1, then image is of the same size as that of the object. So please write down all these conclusions, and these would be utilized for your numerical. So whenever we are solving numericals related to spherical mirror, first thing we have to do is we have to write given, and in given we will have to consider these symbols, plus minus plus minus. We will be also understanding those numericals in the upcoming sessions. So these were all the conclusions based on the sign convention for spherical mirror. In the next part of the video, we will be talking about what exactly is mirror formula and formula for magnification for spherical mirror. In the meantime, if you have any question related to the concept we have done till date, please put it in the comment box. That's it from my end for the time. Thank you and have a great time. Bye-bye.